Hi guys, this is Reshwant and you're watching SaiTutorials. Hope you guys are doing very well. And in this video, we are going to discuss about variables. So what is variable? Variable is nothing but it's a container or reference name for the literals. Okay. So what is literal? Literal means nothing but it's a kind of data. So it's a data which should be validated by the Java. So in the previous video, we already discussed what are the data types we have in Java, right? So this is the data. Literal is the data which one of those data types. So for consider example, Reshwant. Okay, this is a string data type because this word having collection of characters. Okay, this is a string, and for this string we have one a variable name. Okay, name. So, and we are assigning by using this equal symbol. So like same way here also we have another string side tutorials, and this is a variable name channel name, and we are assigning this channel name by side tutorials. Okay, so what we are doing here simply we are doing is this is the data. The relation is the data, and this is the variable name, right? And we are pointing the data with some variable name. Okay, that is fundamental variable. So why do we need use the variables? We'll see. Because suppose I'm writing a simple Java code right now. I want to print my name for one time. So if I run the code, so I got the output here. Okay. So after running the code, I got the output what I expected. Suppose the same thing. If I want to print for 10 or 20 times. That time what I have to do, I have to copy the same line for 10 or 20 times, right? So if I run again, now it will print 3 times. Okay, now I got the exact output what I expected. So what will happen here right now we'll see. So because it's a small string, I can write without any worry. But if suppose if it's an some kind of big string like which is having 30 to 40 words. Okay, that time what we'll do, we have to write the same content for multiple times, and it is very headache process. So to avoid that one, we have variables here. So what variable we'll do here, we'll see. So this is a data, right? Ration is a data, and I want to hold this data by some variable. Okay, I am giving the variable name as name, and I want to assign this variable. I want to assign this data to a variable by using equal symbol. Okay, and in the first video I already told you Java is a static programming language, which means we need to define the data type of the variables. So here we need to mention what data type this name is holding. So this is holding the string, right? So we need to mention the string here. Okay, so this is how we need to declare and initialize the variable in Java, and we need to use the semicolon for each and every statement end. So now this is my data, and this data is holding by some variable. So wherever I want this data, I can without copy and pasting, I can simply use this variable name. So if I run the project, see, I got the exact same output, right? So what's like there's another purpose of the variable. So suppose if I instead of using the variable, if I mention the Reshwant here for 3 to 4 times, suppose and in the future if I want to change the string here, okay, instead of Reshwant, if I want to mention side tutorials, at time what will happen? I have to replace this value for for 3 to 4 times. Okay, so wherever I written the Reshwant previously, those so at that places I need to replace this value, and it will be very difficult. So but if whenever I'm using variables, I can like by replacing only once I can reuse the latest value here, right? Again if I run the project, see, instead of Reshwan I got the side tutorials. So this is the beauty of the variables. And here Reshwan is the literal, okay, because it's a data, and name is the variable name. Okay, so in Java we have a lot of data types, right? So we will see each and every how to declare a variable and how to initialize a variable. So in Java, what are the data types we have? First is short. For short, I can give the name short variable. Okay, and it's not mandatory to assign the value at the same line. Okay, so we can simply declare, which means we need to like declare means like we are creating one variable for the short. Okay, so this is nothing but declaring. And second data type is int here variable. Okay, third is long variable, and float variable, and next double for double variable. Okay, and next we have char variable, and string. So here you need to mention, if you see properly here, for each and every data type like short, int, long, float, double character, so everything will starts with small letters, right? but only string starts with capital letter. And the color also here, if you see, it's reddish color. Why it is like for string alone, why we need to use the capital here? Because the string, like the string is not a like normal data type in Java. It's a class. Okay, like how here we mentioned main. The same way in Java we have string as class. Okay, and we will discuss that also later. So now we finished how to declare the variables, right? Now we will see how to initialize the variable. Means how to assign the some value to the created variables. For that we need to use the variable name equal to some value, okay, 3, and integer variable 4, and long variable 5, and float variable 3.14, and double variable same 3.14. Okay, and for character variable. So instead of giving the data directly, for character, what we need to do is we need to wrap the data inside the single quotes. For that, okay, we need to use single quotes, and inside single quote, I need to give any character. Okay, it may be any character symbol, anything. Okay, and for string, we need to wrap the data inside the double quotes, and I can give any data. So I'm giving a label. So even though if you don't give, like if you give the single character inside the string variable, I mean inside double quotes, it will consider as a string only. Okay, and here I'm giving apple here. Okay, so now if I print the data, what will happen? We'll see. So I written all the print statements here. Now we will see after running the program. So before running the program, I want to remove these two lines. Okay. So instead of removing, I'm just keep commenting, which means the compiler won't read these two lines and it will only execute the remaining lines. So now if I run the program, sorry, here also I want to give comments. Okay. And if I run the program, okay, I got the exact output, right? For short it's 3, for integer 4, for long 5, and for character it's at the rate, and for string it's apple. Okay. So we got the exact output. Now we will see for float and double. If I try to execute this code, now I will end up with some error. Okay, so it's saying like incompatible types, possibly lost conversion from double to float. So what does this error mean? So this hunting button, there is a chance of losing of data. It's saying. Okay, so how, like why it's saying like that? We'll see. So in Java, for the float consists of 4 bytes of space, right? And for double, it is 8 bytes. Suppose, like I want to tell one more thing, like for integer data types. So what are integer data types? Which means short, int, and long. Okay, short, int, and long. Okay, these three will come under the integer data type, which means like whole numbers. Okay, and for integer data type in Java, int data type is the default data type, and for decimals, like for they're having which is having like float and double data types. Among these two, double data type is the default data type in Java. Okay, here what's happening, we'll see. Suppose if I mention short s is equal to 3. Okay, what will happen? The compiler will come to this and it will try to read the code. And here what will written? We written that 3. So it comes under integer data type, right? So which is nothing button. By default, it will consider this 3 as an integer data type. And when you assign some value here, like short you are mentioning, what will happen? It will try to convert the data into short. Okay, and for short in Java, it consumes 2 bytes of data. And for int, it's 4 bytes of data. And for long, it is 8 bytes of data, right? So what will happen? Now you're having some data which is having in 4 bytes, and this data is converting into short, like which is 2 bytes. So what will happen? So here when you read, like there will be no error will come so because this data will can be held by the short. Okay, and the same thing when you done in decimals, like if I mention any float f is equal to 3.14. Okay, so in this case we get some error. So what error we got? There is some incompatible types, possible logic conversion. So why it's happening like that? So when the compiler try to read this line, it will read the value first. So 3.14. So 3.14 means it's a decimal number. So by default, it is a double data type. When you are trying to convert that double data type into float, what will happen? You are trying to convert 8 bytes of data into 4 bytes of data. So that time what will happen? There is some definitely lots of data will be happen, right? Suppose consider a jar. Okay, so inside a jar we have some milk. Okay, so this jar capacity is only 1 liter, and you have another jar which is big one. This jar capacity is 5 liters. So this time what will happen? So now I'm having some milk in this 5 liter. Like I have full to brim. I have milk. Okay. So what will happen? Now I'm pouring this milk into 1 liter of jar. So in this case, this jar can only hold 1 liter of milk. Remaining 4 liters of milk will be wasted, right? It will be spilled it out, right? So the same way, when you're converting the 8 bytes of data to 4 bytes, what will happen? It can the float can only hold 4 bytes of data. So remaining 4 bytes of data will be will be wasted. That's why to avoid that problem, the Java does not allow that conversion. But but we know that 3.14, right? The 3.14, which comes under only 2 bytes or 3 bytes, okay, which is comes under 4 bytes only, okay, it does not exceed 4 bytes. That time why don't Java does not allowing this convention, we will see. Okay, and the same thing happening here also. When you are assigning the 3 value here, okay, what will happen? The integer data type trying to we are trying to convert the integer data type to short. Okay, so that time also there is a possibility of 2 bytes of data losses, because short can only hold 2 bytes and in integer is 4 bytes. So inside 4 bytes, when you try to convert, 2 bytes of data will be stored and remaining 2 bytes of data will be wasted. But that same error, it's not occurring in this case. Why it's not occurring? We'll see. The Java knows this 3 comes under 2 bytes of data. Even though if it is integer, what will happen in case of integer? Integer, we have 4 bytes, right? 1, 2, 3, 4. Okay, we have 4 bytes of data. Okay, and inside 4 bytes of data, these 3 only consist of only 1 byte of data only. Okay, remaining 3 bytes will be filled with some dummies like some zeros. So Java knows very well these 3 bytes, like which is filled with zeros, these are dummy values. So my only actual data is only 1 byte only. So the short can handle this 1 byte. That's why the Java can allow this expression. So this is valid. So what's happening in the float? As you know, in the previous video we already discussed how floating points will be stored inside the memory address, right? So when you're trying to store the data of float or any decimal, what will happen is instead of storing the value as 3.14, it will store some big value like 3.140000456 or something, some random numbers you will store. Okay. In this case, there will be long value. Okay, because by defaultly any decimal value will be converted into double only, right? So when you are trying to convert this big value into float, so definitely this value is not can't hold by the float, because these big value. Okay, so it consumes more bytes. So that's why if I convert this data to float, what will happen? The float only can hold partial data, like maybe up to here it will store. Okay, I mean, so up to this data will be stored, so remaining values will be lost. That's why to avoid this problem in case of decimals, we have some the compiler is throwing some exceptions. Now I hope you understand why we got that error. So now we will see how to avoid that error. To avoid that error, we need to use f here. I mean, this is the value have to store like float. Okay, so that's time in the previous video we discussed the memory architecture for the float, right? So we have exponent for the 8 bits only. So when you were mentioning 3.14f, so it will store the data like in the previous video, how we discussed. If you don't mention f here, how this data will be stored in the memory? It will store as a double, which means it will give 11 bits space for the exponent. Okay, and that time we can't able to store the data in the float variables. We need to mention f here. Okay, for long also, suppose this 5 is only like which comes under 4 bytes only. That's why this expression is allowed. Suppose if you are giving more data, like which you are exiting more, like more than integer data type, like if you see this value, okay, which is definitely exit than the 4 bytes. So that time this is an integer, and the integer can't store in the long. Sorry, this is not integer, right? So when you are trying to store this data inside the integer, it will have 4 bytes, and it try to The Java tried to hold this data in 4 bytes. That time it can't able to hold, right? So some of data will be still pending. So in this case, what will happen? It will try to convert the data into binary, right? So it will suppose this data will give me 6 bytes of data. I have 6 bytes of data for that value. 1, 2, 3, 4, 5, 6. Okay. So assume these are the datas. Okay. These lines are the datas. Okay. Some boxes. What will happen is that value is converted into 6 bytes. But in Java, for the integer data, we can only hold for 4 bytes only, right? So what about remaining 2 bytes? So this data will be lost. That's why to avoid that problem, Java does not allow that expression. Okay. So to avoid that expression, we need to mention that the data type is not integer, that is long. Okay. So for that, we need to mention L here at the end of the data. Okay. That time what will happen when it's storing in the memory architecture, it will read this line. I mean, it will read this character and it will try and it understands. Okay, this data is not integer; it is long data type. So it has to store in 8 bytes of data. Okay. So this is how the data will be stored in case of variables. And also one more thing I want to tell. So I want to run this. Now if you see, we're not getting any errors here. So we got the exit output. See. And also I want to show the data like how double will store. Okay, here what happens is we have like some operations like suppose for the float the operation value is around 6 to 7 bits. So from the decimal point we need to count 6 points. Okay, 6 to 7. So in when you're seeing 6 to 7, what will happen? The value is 3.14.000, right? So it will consider as 3.14. So it will round up the value. So what is rounding the value? The println. So this statement, I mean this method is rounding the values. Okay. And for double, what will happen? For double, we have 15 to 16 bits, and we need to see 15 to, I mean from decimal, we need to see 15 to 16 bits. Okay. And based on that value, it will round up the values. And here I'm giving double value only here. So in case of 0 0.3, if I give, so it's still rounding up. Okay, I want to show one example here. So I'm creating two variables in like double variable d1 and I'm assigning the value 0.1. Okay, and again I'm creating one more d2 equal to 0.2. Right? If I print a value, what I'm doing here is I'm doing addition d1 plus d2. So run the code. We see here, as we know, like by adding 0.11 plus 0.2, we only have to get 0.3, right? But instead of 0.3, here we got the big value like 0.0000, and at last we got 4. So why this is happening? Because this is happening. Whenever you're giving some 0.1, it will store in the memory architecture for the double, okay? And it won't store exactly 0.1. It will store like 0.0000, and it lasts like 0.1 or something it will store. Okay, the same way this code also will store like the same. So at last when you perform addition, Java knows we need to give the full data. Okay, that so this time it won't round off the data. That's why it shows the full data. Okay, so this is how the memory architecture will store in case of decimals. That's why we need to give for float f, and for double we don't need to give anything, and for long also we need to give l. So instead of point, I can give underscore also. See, I got the same output without any error. Okay, like this is a format how we can instead of dot we can use underscore. Now we will see operands and operators. So what is operands? So operands are nothing but some variables. Okay, suppose if I'm doing some arithmetic operations like for addition, example a plus b. Okay, so what will happen here? A and b are the operands, and addition symbol plus is the operator. So by using this variable, we can perform some arithmetic operations also. So we will see what are the operations we have in Java. Okay. So for that, I'm removing this code right now, and simply I'm taking some int var is equal to 4, and another int I'm taking int var 2 equal to 5. Okay. So in Java, we can perform addition. I can use another variable to hold the result equal to int var plus int var 2. Okay. And if I print the result, I can get the expected output. Okay, so 5 plus 4 is 9. Okay, and we have suppression. So what I'm doing is I'm doing add result int sub result var 2 minus int var 1, and also we have multiplication int mul var 2 var 2. So for multiplication, we need to use the star symbol. And for division, int div result where 1 by where 2. Okay. So here what will happen is, uh, so int var is 4, right? And the int var 2 is 5. So what will happen? It will give some 0 point something value will give. So that value will be round off because this is an integer, right? We are doing integer divisions. That's why what will happen? It will round off the value into integer only. So even though it's the value will be like 0 point something, it will return only 0. But also I will show the result to you. Okay, we got only 0. So if I do int give result 2 equal to int var 2 I int var 1. Okay. So in this case, what will come? It will give 1. Okay. So this is how the division will be happen because of integers. And we have one more thing, modulo. So what is mean by modulo? Modulo is something contain reminder. Okay. So the expression will return the remainder. The remainder, I mean, I can give modulo, right? Modulo result equal to int var2. For modulo, we need to use percentage symbol. Okay, 5 modulo 1. So what will be the remainder? The remainder will be 1 only, right? So we got output as 1. Okay, and we have some more operators. We have something called post increment and post decrement. Also, we have pre increment and pre decrement. So what is meant by post increment and post decrement? So it means hunting button into var. Okay, I'm taking two examples. Suppose so my interval is 4, right? If I run the code, what do I get? I get 2 times 4. So I have two statements, right? 4 4. Okay, I got the exact output. Now if we use post increment, what's meant by post increment? Increment means adding, right? So I'm adding some value. So how much value I'm adding? Only one value. That also post increment means after return the data, we have to increment the value. See, now what we got in this line, we got 4 as output, but in this line we got 5 as output. Okay, and what happening here we will see. Assume this is a memory. Okay, and inside one memory we have 4 bytes of data. 1 2 3 4. Okay, so this is the int var in our case. So what will happen? So we have some statement, right? Print statement in our code. So what will happen? This that line will whenever you're pointing some print statements, it will go to that variable, and in that variable, the value is 4, right? So it will print the value first. So we got a 4, and then it will try to increment the value, and this data will be changed in memory. Okay, and okay, so now it become 5 in the memory. And in the next line, when you trying to again read this value, what will happen? It will read the updated value, right? So that time it will give 5. So this is what happen in case of post increment. And same way in post increment also, after reading the value, it will update the value in the memory. So that time what will happen? So this it initially it will be 4. After post decrement, it will become 3. Okay, means we are decreasing one value. And in the second line of code, when you try to read the value from the memory, we can expect a 3 value. In this case, I'm taking var2 minus minus. Okay, var2. Okay, now I want to keep this code and comments. See, 5 4. Why I got 5 4? Initially var2 is 5, so I got 5. And after printing in the memory, we reduced the value by 1, and then in the next line when you read the memory again, we got 4 as an output. Okay, and also we have pre-increment and pre-decrement. Pre-increment nothing but then before reading the data, we need to increase the value. Okay, for that we need to use plus plus in front of the variable name var. Okay, and for pre-decrement minus minus var2 I'm using. Okay, so if I run the code and I want to put comments, and if I run the code, here you can see 5544. Okay, because the actual value of into var is 4, right? So before printing, it has to increment the value in the memory, right? So the 4 becomes 5, and when it's reading the memory, we can get the output 5. Okay, and in this case also, again it's reading the same value, right, in the memory. Again we will get the 5. Here what we can get? Int var2 is the initial value of int var2 is 5, right? So before reading, it has to decrease the value in the memory, so it become 4. And in the next line also, again when you're reading the memory, you can we get 4. Okay, that's why we get 5544. So these are the codes we have, okay? And we have some more things. So we have some bitwise operators. So what which mean by bitwise operator? We will see. So up to now, what are the operators we discussed? Those are the arithmetic operations, which is nothing but a simple mathematics. Now we will see bitwise operators, which means perform the operations in only binary of a formats. Okay. So for that we have something called XOR operation and bitwise and and bitwise OR. Okay. And also we have bitwise shifting operators. So in bitwise shifting operators we have three things. One is left shift, right shift. Third is unsigned right shift. Okay, so we have three things here. Now we'll start with XOR gate. So what's XOR? So if you remember in our like intermediate or some BTech, we have seen some gates, right? Logical gates. So we have OR gate, AND gate, XOR gate, NAND gate. Like we have a lot of gates. So in that, so XOR also is one of the gates. Okay, and we are doing this operation on the binary. Suppose if I perform an operation here, okay, I'm doing XOR operation here. What will happen? We'll see. Print. I mean, first I'll take one result XOR result equal to int var and int var2. Okay. So what's the symbol we need to mention for the XOR? For that we need to keep cap symbol. Okay. So this is a symbol for to represent the XOR operation. Okay. Now if I print a result, see, we get 1. And why we get 1, we will discuss. Because what is the value of the int var? It's 4. And what is the value of the int var 2? It's 5, right? So 4 cap, I mean XOR 5. We'll see why it came like that. So how we write the binary value of for 4? It's 2 power 2, right? So 1, 0, 0. Okay. So this is the binary value for the 4. Okay. So remaining all the bits will be filled with zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this 1 byte and remaining 3 bytes we have in front. So those 3 bytes also will be filled with zeros. Okay. So this is how we represent the 4 here. Now how we represent 5 here is nothing but 0, 0, 5, 1, 0, 1. Okay. And this is the binary format for the 5. Okay. And here also we have 3 more bytes. These bytes also will be filled with zeros. Okay. So zeros, zeros, zeros. Okay. So what exactly XOR will do? So we have some kind of formula or something we have. So instead of that, we can simply remember one thing. So whenever you're doing some operations, okay, suppose 1, 0, 0, we're having, okay, right? And here we're having 1, 0, 1. So always when you perform XOR operations on between two variables, what you do is you just simply count the ones. Okay. So in this place, how many ones we have? We have only one, right? So whenever the number of ones is like the count of number of ones is odd, the result will be 1. And if the I mean number of ones is even, the result will be 0. Okay. So if you see here in this place, we have 0, 1, which means only one number we have, like which is odd. So 1 here, and here 0, 0. 0, 0 means 0, right? Like we don't have any the count of the ones are 0. So 0 is also an even. So that's why here 0. Okay. And here we have 1, 1. So totally we have two ones here. So two ones mean two. I mean 2 is the even number, right? That's why again here 0. So this is the final result we get. If you convert this binary number into again decimal, the result will be 1. Okay. That's what we got here. So here we got 1, right? That's how we need to do the XOR operations. Now we will see bitwise OR. What we mean by bitwise OR? So bitwise OR like something maintain. It's like a normal OR gate. Again, I'll show with the example. Int var and int var. I mean int var 2, right? And I want to show this result in some variable. For that I'm giving OR result. Okay. And what is the symbol to represent the bitwise OR? For that we need to mention the type symbol. Okay. And here I am printing the result. And what will the output will see? See, we got the output as 5. And why we got the 5 as an output we'll discuss. So here also the values are 100 is the bitwise binary representation of the 4, and 101 is the binary representation of the 5. Okay, and here we have a lot of zeros in front of this, so it's okay. But we only consider this only value here. So here, if you see, again we need to consider the last, these values. Okay, suppose if whenever performing some bitwise operator, what will happen is here a 0 represent false. Okay, and 1 represent true. Okay, so 0 represent false and 1 represent true. So here in OR operator, how it will be, right? Even though if we have at least one, one true, the result will become true. Okay, if you don't have any truths, the result will become false. So here what will happen? This false and this is true. Okay, so we have one true, right? So at least one true we need to we have to become true. Okay, so it become true. So one here and 0 0. So there is no truths here. So only false means false. 0, and here true true, so at least one true I have, but I have two here, that's fine. Okay, so 1. So if you convert this value again to decimal, we got a 5, right? Exact 5 we got, so that's the answer we seen in the in this compiler. And we will see bitwise and. So what is bitwise and? Bitwise is not, and is nothing but an it's just like or, but we need to have all the truths, where int where 2. Okay, and I want to print the result and result. Okay, so which symbol represent the bitwise and here? It is nothing but ampersand. Okay, so if I run this program, I get the output as 4. Okay, and why we get the output as 4? We'll see. Consider the same example here. So 0 0. Okay, so here what in case of and, what we have is we should have all the truths. Then only the result will become true. If we have at least one false in it, the total result will become false. Okay, so here we have false. That's why on here we have false. So 0. Here false false. So false. Here true. Okay, and next one also true. That's why the result is true. Okay, 100 means 4. Okay, that's why we got the answer as 4, right? So up to here we completed the normal operations. Now we will see shifting bitwise shifting operators. So we'll discuss first thing is left shift. So how left shift will work? Nothing but an left shift left result. For this we need to use only one operand. So these shift operators only work on the single operands, not like here we are doing like between two operators we are doing operation, right? It's not like that. It's only work on the only one operand. So I'm taking into var. Okay. So here I need to mention some value like 1 or 2 or 3, like anything, any number. Okay. And the symbol to represent the left shift is two less than symbols. Okay. There should not be any space in between of the these two symbols. Okay. And if I print the result, see we got a 8, and the actual value of the interval is 4. And why we got the 8 is like which means when you're doing left shift, which means so we are doing the multiplication of this value. So which means 4 multiply 2 power 1, which means 4 into 2 equal to 8. Okay, so now this become 8. And this is how we simply perform the operations. But in case like if you try to understand how it's happening in like it binary level, we need to again see the example. Here we're having 4, right? For 4 we need to mention like 1 0 0 in binary. Okay, and we have a lot of zeros in front of it. Okay, so this 1 byte and remaining 3 bytes also will be filled with zeros. Okay, so here what we are doing is we are shifting the operators, means we are just rotating the operators. It means suppose this is my frame. Okay, okay, so the total thing is my frame. Okay, now in whatever in this frame, whatever the binary details will be inside the frame is my result. So what will happen? We are shifting the operate by using shifting operator. How many bits we are shifting? We are shifting one bit towards the left side. Okay. So what will happen? Whatever the bit here which present inside, I mean, it the first bit will be go out of the box. Okay. So and whenever it's moving, what will happen here in the at last we will get some occupancy, right? We'll get some vacancy. That vacancy will be filled with zero. What will happen? 1 0 0 is my binary representation of my 4. And when we're shifting the when you are doing some one shift here, what will happen here inside the frame? We got one more zero here, and the zero which is present at different will be gone out. Okay, so now so we have all the zeros here in front. Okay, now these the result. So if you read this, if you convert this binary into decimal, you will get 8 as a result. Okay, so this is how the left shift will be happened. So okay, now we got one. Now we will see one example as well for the on this same problem. Now if I shift the value, okay, I will take one more example here. Int a is equal to 258. Okay, I'm taking this value as my integer value, and what I'm doing is I'm doing left shift, left result. Okay, is equal to a left shift. How many bits I'm shifting? Suppose 4. Okay, print result, left shift, and left result. Okay, now if I print the answer, we get 2 power 4 into 258, which means 2 power 4 means 16, right? So 258 into 16. Now we got 4128, and we got 4128. Okay, so this exact output we expected. So now what will happen if I mention here 8? Again, if I run the program, okay, now we got some more big value. Okay, because 258 into 2 power 8. Okay, like that, if you increase the value here, we can expect the more big values. Suppose if I give 30, like somehow we got some negative value in case of some big value, like some uh, positive max value. And again, if I give here 31, what will happen? I got 0. Again, if I give 32, 258. Okay, again if I give 33, again I can get the 516. Why this is happening? Because as we know, this is an integer type, right? Integer data type, we have only 4 bytes of data. Suppose I have 100, right? When I'm doing some 31 operations, I mean 31 shift, what will happen? This, oh sorry, 31 or 30, 30, right? Maybe I guess 30 only. Yeah, 30 only. So I have 30 shifts. Okay, and here 31, 32. Okay, so at 80, like if I perform 30 shift, what will happen? This one will come to front, right? At that time, what will happen? The result will be 1 0 0 0 0. So all the remaining 4 bytes will be zeros. Okay, if you convert this binary into decimal, we get some negative value. That's the maximum negative value we can get in Java for the integers. Okay, so so that's the value we got. Okay, and again when I perform 31 shift, what will happen? This one, right? Again is go out of the box. Okay, that's why again that time what will happen? My in my 4 bytes, all the values will be filled with zeros, right? That's why I got the output as 0. Again when I do 32 things, I mean 32 shifts, what will happen? I got the 256, sorry 258. Why I got? Because in Java, so we can only perform 32 shifts for the integer. Why? Because 32 means 4 bytes, right? And the integer size is 4 bytes, right? That's why we can only perform 32 bytes, I mean 32 shift left shifts only. We can't perform more than that. If you perform that more than that, like 33, 34, so what we get again, the process will be start from the beginning. Okay, so here simply what will happen is, so suppose here if I perform 32, right? So here what will happen is, here the compiler put modulo 32 here. Okay, and here what will get 0. 0 means there is no shift, so the actual output will be actual value will be printed here, right? And if we give 31 33 here, so in case 33 what will happen, the remainder will be 1, right? So a shift 1, a shift 1. Okay, it means only one shift happening, that's why we got by 16 as output. Okay, so like this it will be happen. Now I hope you guys understand how left shift will be done, right? Now we will see right shift. I know like it may be like boring for you, but it's mandatory because when you are doing some proper problems, at time these concepts are very very important because when you are applying for the Amazon or Microsoft, those companies, we can expect bitwise problems in the coding rounds. Okay, that's why we need to be very focused on these topics. So what will be right shift? So in case of left shift, what we done? We just move the bits towards left, right? So in case of right shift, we need to move the bits towards the right shift, okay? And in right shift, we have two types. One is signed, second is unsigned, okay? And if you mention right shift, it basically indicates signed. So for that, int a, again I'm taking the same value 258, and int right result equal to a. For right shift, we need to mention two greater than symbols, one right. Okay, so simply in the left shift what we tell, we are multiplying the value, right? Here we need to divide the value, so a division by 2 power 1. Okay, so 2 power 1 means 2, and if I divide 258 by 2 means I get 127, right? Sorry, 129, my bad. I guess I'm weak in mathematics. Okay, so we got 129 by two steps, 258 by 4, 64. Okay, so like this we can expect this output. So these fine for the positives. What about the negatives? If I give the value as negative, see, instead of we got a 64, we got minus 65. Why we got this value? So for that again we need to explain. Okay, we have 4 bytes, right? One, 2, 3, 4. Okay, we have 4 bytes, and if you consider example for 258, it will be around 2 power 7 something. Okay, 0 0 0 0 0 7. Okay, so if I'm not wrong, this is the binary representatives of the 258. Okay, so like that we have a lot of zeros. So here also we need to highlight this thing first bit, okay, because this is the sign bit, right? But integers, and for sign bits how it will be indicate, 0 represent positive and 1 represent the negative. Okay, so suppose in case of uh, positive 258, that time what will happen, here I have the 0, right, to represent a positive, and here everything will be zeros. Okay, when you are right shifting, what will happen, suppose this is my frame, so this is my frame, right? So whatever the data which present inside my frame is my result. We are doing right shift, which means that the binary has to move the right side. So if we give right shift 1, which means we need to move the binary 1 bit towards right side. What will happen? That time we will get one vacancy at the right side, I mean left side, and this 0 will be omitted. I mean will be gone out. Okay, when this data will be gone out, I mean the last 0 will be gone out. Here we have one vacancy. Okay, again this vacancy will be filled with 0 only, because the value is positive 258, right? Because the value is positive, that's why we need to keep 0. But in case of negative, suppose if you consider minus 258, what will happen? So instead of 0, the vacancies will be filled with 1. So for two shifts, what will happen? It first one, I mean one time one will come. In the second shift, again two, another one will come. In third shift, if I done, again three ones will come. Okay, like that, the ones will be keep on increasing. Okay, and this right shift also will be only performed by 32 times only, because the size of the integer is 32 bits only. So we can only perform 32 times, I mean 32 shifts only. After that, we can't get any output. Again, if we perform also, the compiler will just keep modulo 32 for that given number. Again, the same results will be keep on to repeat it. So this is how the right shift will be done. And we have one more shift, which is nothing but unsigned right shift. So in unsigned right shift, there's nothing to tell. Whatever the value, whether it is positive or negative, only zeros will be replaced. Okay, there is no concept of ones in that case. And to represent the unsigned right shift, we need to use the value 258 int unsigned result equal to a. For the unsigned right shift, we need to use 3 greater than 2. Okay, print my answer unsigned. Okay. Now what will happen? 258 divided by 4, 64, right? Now if I keep minus, right? So this is the output we got. And why we got this output? Because minus 258 will be how we can represent the minus 258 in the binary. Something like one zeros. Wait, I will show you. Something like 1, 1, 1, 0, 0, zeros. Something we have lot of zeros. Unlike that, some value will be there. Okay, right? And I will consider this is my frame. And because we are doing unshift right, I mean unsigned right shift, what will happen? It will the values will be only occupied with zeros only. I mean all the vacancies will be occupied with zeros only. There is no concept of ones, right? We said. So if I move 2 bits right side, what will happen? Here 2 bits will be omitted. I mean 2 bits will be go out of the box, and 2 bits vacancies will be occupied here, right? And those 2 bits will be filled with zeros. Okay. But in case of right shift, I mean which is signed, if it's positive, it will be filled with zeros, or if it is negative, it will be filled with ones, right? So this is the only difference between unsigned and signed we have, right? So I hope you guys understand the operators very much. So if you guys like this video, please like, share, and subscribe.